Kubernetes logging. I'm working on in the collective sense. There's a startup, and we do a couple of things. One of them is we gather logs, and we gather logs from the Kubernetes. And because of that, we know a couple of things about this. So I'm going to share my experiences with you about that. But let's start with some simple things like our applications. Because we have our applications, we get the logs from the applications themselves, right? And how do we do that? We can, log straight into the log file somewhere on the disk. We can use some remote location somewhere in the, in the cloud or in our data center or what have you. Or we can log using the standard output and the standard error, or we can use all of those three techniques at the same time to gather logs from our applications. And if we have, Go application or Java application, that doesn't matter. You just log, and this is really simple stuff, right? So that was like in the a couple of decades ago, and it was fun, right? One of those three things is better than the others, and the better thing is the standard output and error logging. And why is that? Because we don't care about the logs themselves. Where are they going to be stored? If we store our logs, if we use standard output and standard error for our logging, we can say to administrator of the system, like, come on, this is the standard output. You have like multiple applications, so you know where you want to store the log files, and I just give you those logs. You do with them whatever you need, so that it is consistent throughout the whole system, right? This is 12-factor up compliant, which is a good thing. Actually, yesterday and in this very room on the same time, I guess it was by Wojtek presentation about the 12-factor app. This is really good thing to know and to follow. And 12-factor app as well says that we should use the standard output stream. This is a problem with the standard output because sometimes we have logs which are multi-line, right? Have you ever seen the Java stack trace is like many lines, right? And they that don't have much sense if they are treated not at the same time together. And if we use the standard output, this is tricky a little bit. If we use those two techniques, like if we use remote location, so we use some libraries to log files, then we don't have these multi-line problems, because many times the libraries take care of the multi-line logging. Okay, so then the Docker came. So we have our applications, and the Docker again do something with the logs that are run in the containers. And how can we gather the logs from the Docker containers? So I don't know if you know this. We have two versions of Dockers. This is Enterprise Edition and the Community Edition. And if we want to use logging drivers, there are many logging drivers for the first paid version, which is Enterprise, and not so many for the Community Edition. In the Community Edition, we have 3 logging drivers by default if we don't pay. This is local, this is JSON file, and this is journal.d. Or no, no, this is not like that. Sorry, I made a mistake. If you want to use Docker logs command, you will see logs from those 3 logging drivers. Maybe you can use all of the logging drivers in both versions. Like there is, you can put logs to Elasticsearch and so on to fluentd logging drivers, but you cannot use the Docker logs command. And this is tricky because this is not really convenient. You know, sometimes log in into the server and you won't just see the logs from the Docker container, and you type Docker logs and you see only the text like you are not allowed to see the logs because you are not using the proper driver. Just pay us and we'll let you do that. This is not really helpful. There are some other problems with those drivers in Docker, like those drivers sometimes die, and we have container and the driver is not working, so we don't have logs because the driver does not log anything. And other thing is sometimes our logging as a service dies as well. And if we don't store the logs on the server, they are gone. So we just don't see what was happening with our application. And because of that, I think that the best thing to log in using Docker containers is to use the JSON file, which is just storing logs on the machine, and then scrap those logs from the local disk and put them somewhere else. And how to do that? The Docker stores files in this location, which is well known. This is a container ID, and again, the container ID -json.log, and we have our logs. And the logs look like that. We have the log in here. We have the stream, which is standard output or the standard error, and we have the time of the log. So the whole log is a structured log, and the log itself is unstructured. It's just a string. Okay, and that was fairly easy, right? Because this is not complicated, but we are human beings. We don't like when things are simple because we want to try new things. So try new things, break and fix them, and use Kubernetes, of course. This is a little bit different story because we still have applications which are run in the containers, but now we have those containers everywhere, like in multiple locations. And by default, how does that work in the Kubernetes? So we have pod, right, and the container inside the pod, or multiple containers. And by default, if our applications is logging to standard output and standard error, we have this log file stored somewhere on the server, and Kubernetes takes care of the rotation of the log. Right? This is important thing. This is convenient, right? For a couple of pods, but not really convenient if we have like multiple. We can use the kubectl logs command, which is nice, right? We just kubectl logs, show me logs from the spot, and we see everything. And also those logs are available on the node itself. So again, we can using SSH log into the node and see what was happening in the kubectl logs does not work. But as I said, this is convenient for the small amount, but it's not really convenient for the big amount of pods, because if we use Kubernetes, we have multiple pods on the machine, right? And this is true for containers as well. But there is a difference because we don't only have one server, we have multiple servers if we use Kubernetes, right? So if we want to see logs from all of the applications, I don't know, maybe we just open multiple SSH connections to and tail the logs from all the applications and see that this is like multiple things at once, and this is just not going to work. So how do we do that? And we do this using and here are a couple of architectures how we can do that, and almost all of them are good, but we can use whatever we want. First of all, we have this logging from the application. This is a fairly easy, right? So this is the first scenario, as I said at the very beginning. We just have applications. The application is just logging somewhere in the remote locations. This is okay, but there are some problems, like the kubectl logs does not work anymore. because the logs are not on the server itself, so kubectl cannot scrap the logs and show us them. We are dependent on the available libraries. So if we, I don't know, have homogeneous environment, we use, I don't know, Java, Python, Go, and what have you, then we need to have proper libraries for our logging backend. This is not 12-factor compliant, but it works for the multi-line logs, as I said before. There is another form of this, which is sidecar container with logging agent. This is almost the same, but the scenario in here is that we have an application which cannot have these libraries added. So how do we do that? We can log from the container into the file, which is local to the pod, and then we can run another container inside the pod, which is a logging agent. And this logging agent can scrap the log file and put it here into the logging backend. And this is cool, but we have some problems. First, we have the same problems like we were logging directly from the application. We lose the possibility of the multi-line logs because now we have this file in the middle, and because we have this file in the middle, there is a problem because here's the file and it's not rotated. We need to take care of the rotation of the file, right? Because there is a disk underneath. So we need to take care of that, and Kubernetes is not going to do that for us. The third scenario is to use the node agent, and it's better than the previous two. And how does it work? We have application container. It logs to the standard output, standard error. This goes into the log file, which is rotated by the Kubernetes. And additionally, we have this logging agent pod. And this logging agent pod is running on every node in our Kubernetes cluster. And because it is running on every Kubernetes cluster, it scraps logs from every container and every pod that is running on the node. And it's its job to put those logs into the logging backend. Yeah, and it works like that. It pushes just the logs somewhere else. We use the daemon set for that in the Kubernetes itself, because daemon set tells Kubernetes to run only one pod of the kind on every node. Logs are still available using the kubectl logs, so we just don't lose this possibility. This is cool, and we have again this problem with the multi-line. And there is another twist to that. If we again have this application which cannot log into the standard output, this is some legacy application, we just can use the streaming container in here. So instead of going with those logs from here into the logging backend, we just stream into the standard output and standard error, and again we have the same scenario as before. It works for the multiple files. So if we have multiple files, for example, I don't know, in Elasticsearch we want to use GC log and some other log, we can have just multiple sidecar containers in the pod, and we are good. And again, we have this space problem, because now we have here are the log and here are the log again. This one is rotated, this one is not rotated, we need to rotate it by ourselves, and this log is taking twice the space, right? Okay, and how to do that? This is a simple example. We can use the mount path in our Snowflake container, which is just var log, and then we run another additional two containers, which are just those sidecars. They have the same var log mount path, and those sidecars can just tail the files one by one. This one is tail 1, this is tail 2, and now we have, using the kubectl logs or some other techniques, we can see the logs from the one file, and here are the logs from the other file. This is easy. But which one to choose, right? I know, I'm sure that for you now this is obvious, right? I do not recommend to use those two techniques. So logging directly into the logging backend somewhere, because we lose many possibilities that are life-saving sometimes. This is okay if we have the streaming container, if we need to use it, but if we don't have to, this one is much better. Just use the log file directly and use the log agent pod, and you're good to go. Of course, all of them are usable, right? I'm not saying that we should use this technique every time. There are some cases when the other ones are okay as well, but if we can, just use this one. Okay, and technically, how to do that? You can just use the fluentd to achieve this. Fluentd, I know, we should all know what it is, right? It is under Cloud Native Computing Foundation, like the Kubernetes itself. And it has this daemon set for the Kubernetes. It's prepared, so it just plug and play. And it is recommended by the Kubernetes official documentation. It just works under the Kubernetes. How does it work? We just can, use the daemon set. We use the mount path for the Docker containers, right? And here, this daemon set use the host path, so it takes the logs from the node itself, and because of that, it has the access and can just push the logs from all of the containers somewhere, and we can then grab them. There's a question if we should log everything. If we use Kubernetes, then it means that we have some certain scale, and sometimes it just does not have sense to log all the things, right? I mean, our application can log everything, but it's not cheap to gather those logs and ingest them somewhere, right? Because we have to store them and keep them and rotate them and this kind of things. And sometimes we just use, we can just have, a glimpse of what is going on with the applications to know that there are some serious problems, right? We just don't need to see thousands of problems with connections from Postgres. We just want to see, we can see 2 of them and we can know that there is something wrong, right? Because we don't use this Kubernetes because it's fancy, okay, I said this, we can use this fluentd plugin throttle. If we use fluentd, we can just say many things like, I don't know, I want every 100th of, or I want every 10th of the log from this applications and so on, and it's just that, right? It's really easy, and sometimes I'm pretty sure we just don't need all of those logs. Okay, and the other question is where to store them, right? First of all, we can use the Elastic Start from the Helm. This is as easy as this, and you just have Elastic and I believe Kibana as well, and it's up and running. Or you can just use the logging as a service and just send the logs somewhere else, right? I will not be talking about the Elastic Start because I'm working on this Logsense, but this is the things that I will be showing you are not really Logsense specific. This is how you can install our logging agent, and it's the same for other logging as a services, like, I don't know, yeah, there are a couple of them, but this is simply the same, right? All of them are using the fluentd daemon set, and almost every time you just need to create some kind of a token into your system and then just apply the daemon set, and fluentd takes the credentials and just start working, and this is the same for us. And if you start gathering those logs, what fluentd is doing for you? Here are the example of the logs. This is the log from the application itself. This is from the Kafka, but we get some additional information from the fluentd, and fluentd has them gather them from the Kubernetes. And there are lots of information like container name, namespace, pod name, container image, and so on, all the labels, host, and so on. This is important stuff. Why? Because when we put all of those logs in our logging backend, we need to query this backend. And we want to see logs from one applications and not from all the applications, right? So we need to filter them. And to filter them, this is a screenshot from Logsense actually. You can use some, you can use those metadata, right? So you type logs Kubernetes and namespace, then you say I want to see from namespace stage or prod or int, and you have all of those logs. It looks like that in our application. So here I'm showing you the logs from the container, which is Kafka, and Kafka, as you can see, this is one container, but the container itself in the pod is called Kafka, but we have multiple pods, 0, 1, and 2, and we can see that we had 4 hosts, which means that probably one of the pods has been moved from one node to another, and probably it was the Kafka 0 because it has this 75 logs instead of 47. Yeah, and you can look through those logs like that. What is specific to Logsense, and I believe to other solutions as well, but we enrich the information that we gather. So we have the logs, we ingest them, and when we see that, for example, the log was unstructured, so we don't have the information about the log level that was used, right? Because we sometimes use info, sometimes use error, sometimes use fatal, and if we use the driver, some library to log things, the library takes care of this enrichment, right? But if you use the flat format, we just get the string, right? Which is here. And the string is only info deleting something. So there's not the information, we need to parse this. And we do that actually. So we look for this info or stage or something, and then you can look through the logs using this enrichment. So you just don't have full text search, you have this smart search as well. Okay. The other thing is that again, this is this simple flat log, this unstructured one. The whole log is structured, but our log that we are interested in is unstructured. And this is what makes the difference for us. This is how Logsense is different actually, because we use those logs to create patterns on the fly. So you don't have to say like, okay, those are HTTP logs, and you have this pattern, and this pattern looks like that, and this is really error prone, right? We do that for you. We look through your logs as they are, ingested, and after some times we see what is changing and what is not changing, right? And because of that, we can create the pattern, and I can show you here. Here we have this Kafka buffers. Process buffers, and we found out that those are just strings and this is changing. And because of that, we created this pattern with this pattern ID. This is some parameter which can be renamed, of course. And then if you have this information, you can easily create a graph, right? Because now we know that this was integer, and because it was integer, you can from your logs get some kind of a metrics, right? So you don't have to have the metrics endpoint, or you can for other things, but additionally you can use this for creating graphs. And because we have this, and we know that those were the parameters can create graphs and so on. Additionally, of course, we use some machine learning, and because we use some machine learning, we can see, like for example, you had the logs and you had this flat, I don't know, 47 amount, and now you have 200. So then comes our anomaly detection, and you get the log command that this changed, right? Like rapidly, and then of course you can stack all of those graphs together to see everything in one single pane of glass. Okay, that was quick. Here are some links. This is from the Kubernetes documentation. It's really good. Docker logging container, 2-factor, and of course the link for the Logsense. One thing that was really cool, and I encourage you to do, is during, when I was preparing this presentation, I found one of the images was lacking some little part of something. Then I just edited this using GIMP and added this into the Kubernetes documentation, and bam, it is there live in the master. It was really easy. So if you find any bugs, just do that, and then everyone can benefit from that. Okay, that's it. Thank you. So thank you for listening. If you have any questions, I'm really happy to answer them, and I'm also somewhere here in the conference as well.
Now I have one question about managed distribution of Kubernetes, because you didn't touch this point. What about your recommendation for Google Kubernetes Engine or Azure Kubernetes services? Should we make logging somehow different for such distribution provided for us from vendors?
That's of course depends on the features that you want to have, right? Because if you have these managed services, you just use, I don't know, Stackdriver, right, for Google something. They sometimes lack the, I don't know, in anomaly detection of the auto pattern recognition and these kind of things. So if this is good for you and you can use them, you're happy. Okay, it's cool, yeah. But sometimes you just want to go deeper and you need more information, and then you just use this Fluentd daemon set and put those logs, and that's it. We use ourselves, so we just don't have this problem. But yeah. Depends on your use case. If you want, just simple. If you just want to look through the logs and just see the logs from the application, then okay, you just can log them into the file or something. But if you want to have some specific things, then I'm pretty sure you need to use something else.